All right, we'll get started in just a minute. So thanks for joining. You joined Silex from micro to full stack. If I go too fast, just let me know. So my name's Dustin Whittle. You can find out more about me at dustinwhittle.com or follow me on Twitter at Dustin Whittle. So I've worked a little bit in the PHP community in the past. My current role is a developer evangelist at a company called AppDynamics that does application performance monitoring. And in that role, I do a lot of consulting on high-scale projects. Previous to that, I was a consultant and trainer for SymfonyLive in the US. And then before that, I brought Symfony to Yahoo to rebuild properties like Delicious and Yahoo Answers. So that's when I contributed the most to Symfony in the early days. It's been a little less than nowadays. But I have quite a bit of experience. I've been in the Symfony community for about 8 years now. And let's talk a little bit about Silex. So what is Silex? I'm sure some of you know at least Flask, Express, or Sinatra. Silex is a micro framework that's built in PHP and it's really standing on the shoulders of giants. And that means that it's really based on the Symfony 2 components with easy installation in Composer and was created by Fabian and Igor. So it's very easy, it's very well documented, just like all the other Symfony libraries. You can find out more at silex.sensiolabs.org. A little bit about the Silex philosophy. So why a micro framework? So Silex being a micro framework does have some conscious limitations. So what are those limitations? So anything that would introduce a command line tool or the need for a command line tool will never be in Silex. That's not to say that you can't build a command line tool inside of a Silex project, but it's never going to be part of the core. Any feature that requires any external configuration files, so anything that requires YAML, XML, INI files, and then any feature that's not PHP. So annotations is a good example of that. And really anything that adds a lot of code to the core of Silex, or extends the application class. So the idea here is that it should be as lightweight as possible. So the goal here is to create a micro framework that's very easy to add features to, and not so much remove like you do with Symfony 2. But why use Silex, or why use a micro framework in general? Oftentimes, full stack frameworks are overkill for simple projects. So if you need a really simple RESTful API, you can use Silex for that. If you need a really simple application, Silex works well for that. The goal here is simply to map a route to a controller. So it's easy enough to do. Now, Silex is really based on the Symfony 2 components, but it's not the same as Symfony 2. The goal here is to be concise, extensible, and easily testable. So all of this talk comes from a previous talk I've done at SymfonyLive. So there's a bunch of code examples that I'm going to go through. They're all available on GitHub, so github.com/DustinWhittle, and you can clone this repository and follow along. So to get started, pretty much everything in PHP nowadays starts with Composer. So if you don't have Composer installed, it's easy enough to install. curl-s getcomposer.org/installer. And then once Composer is available, it's easy enough to define a Composer JSON file and to bootstrap a new project. So in this case, I'm going to walk through a simple hello world application. But the idea here is that for a single file PHP application, Silex provides a default structure, and it's very easy to extend. So here we're going to install PHP 5.3 as the requirements, and we're just simply going to install the Silex package. So a simple Silex application looks like this. You have your Composer JSON file, the Composer log file, and then you have your vendor dependencies and simply an index.php. So if we want to build hello world in Silex, it's extremely easy to do. Again, hello world. All we're going to do is require the autoloader, bootstrap a new Silex application, so app equals new Silex application, and then we're going to map routes to a controller. In this case, I just want to print hello/world or hello/some name parameter, and it's really this simple. So with the application context, we're simply going to add a get URL with /hello/name. So /hello/some parameter, and all we're going to do is return hello and app escape the name from the URL parameter. Pretty straightforward, relatively easy. This is a single application and a single PHP file. This is pretty much as simple as it gets. So with that, you can run PHP if you have it built in. If you have 5.4 and above, you have built-in PHP server. You can simply run php-s and then give it a port and run your application. So /hello/SymfonyLive Berlin, hello world, hello SymfonyLive Berlin. Now, this is as simple as it gets. Now, this is not what you really use PHP framework for, so let's talk a little bit more about real-world examples. So again, everything we just did, you can do with Composer by using the create project command to bootstrap a new project using Composer completely. So in this case, we want to add a Silex skeleton. What that's going to do is provide additional features to Silex project. So Fabian has a Silex skeleton repository, and what it's going to do is provide a couple of useful features. So even though it's minimal, there's still certain features that you need for every application. Features like being able to maintain configuration for a development environment, for a production environment, being able to have a way to manage views. So in the previous application in Hello World, all we did was map a route to a controller that returned a variable. Really straightforward. There's no templates to manage. There's no different environments and configuration to manage. So the Silex skeleton will give you those additional features. So it'll provide configuration for development and for production. It'll provide a twig layer with twig templates and a way to manage layout with templates. And then it'll provide two front controllers, one for production, one for development. And more importantly, it starts to give your project a bit of a structure so that you can start to scale it as you add functionality to it. So you have a place where your controllers can live, you have a console command if you want to run it, and then you have a way to maintain application configuration. So again, we'll run PHP in server mode, and what you'll see is a very simple application. So what you'll notice is that there's a couple of different things that we have in this application that every app needs. Like when I switch in development environment, I want pretty debug messages, but in production, I want you to go to a 500 error page or a 404 not found page. And then there's certain features that you just need. And this provides a basic template for applications. So you get all the Symfony goodness that you would expect. So in this case, you get the Symfony pretty exception pages with all the details. But oftentimes, this is really basic. You need to add features. So how do you add features when it comes to Silex applications? It's relatively easy. So you add new features with Silex providers, and all a provider does is expose new functionality to your Silex application. So everything is managed via Pimple, which is a simple dependency injection container. And again, just like the Symfony community has bundles, Silex has a large community of providers. So most of the functionality you need is already built and available. If you want to interact with Guzzle so you can deal with web services, or you want a memcache adapter, there's no reason to write that stuff yourself. You can benefit from the large Symfony community, where most of those components are just exposed via providers. But Silex ships with a set of core service providers that have all the features you'd expect. So everything from Twig for a templating layer, if you need to maintain state, there's a session layer, forms and validation, basic security layer, internationalization if you need to do translations. And then if you need a basic database abstraction layer, there's access for Docker. But the reality is you can create as many as you want. This is just the way you expose new features. So let's register a new provider with our application that we bootstrapped earlier with Silex skeleton. So with all providers, what you'll see is that these examples are quite repetitious. So they all follow the basic idea of I want to register a service provider with my application and then make use of this newly exposed service. So here, all we want to be able to do is generate URLs for our controllers. In this case, we're just going to call app register Silex provider URL generation service provider. So I want to register this service with the Pimple dependency injection container for our application. And then I want to make use of it. So in this case, I want to bind a route. So earlier what we mapped is the /hello/world, but now I just want to map the home page to a route. And I want to give that route a name. So what we're doing here is we're calling app get / to the home page. And then we're passing in a template that we want to use. But the important piece to focus on is the bind homepage. That's going to give this controller a URL that I can reference later. So when I want to generate a URL for the homepage, I have the context to do so. So that's exactly what we do in the second controller. So when I go to /navigation, all I want to do is print a link to the homepage. So I can use the URL generator service and generate a URL for the homepage. Relatively straightforward. So every app needs a way to map routes. Also, most applications need some way to maintain state. So in this case, we're going to use the session provider. Again, just like in the previous example, we'll call app register, and we'll pass in our provider. In this case, it's the session service provider. And what that'll expose is a way to maintain state between requests. So how do I manage cookies? How do I set parameters? In this case, I just want to set a username, so I'm going to call app session. Again, app is a reference to the container, and session is the service inside of the container. All of these are the Symfony components underneath, so if you're used to Symfony, then you already know Silex. So here we call app session set The name parameter is user, and then the value is username SymfonyLive. And if I want to access this later, I can simply call app session get, and then the name of the parameter, user. So again, relatively straightforward. We covered how I generate URLs and manage routes, and then how do I manage state inside the application. What you'll notice is that every one of these examples, we're just adding on new functionality. One of the primary differences between Symfony 2 and using a full stack and using a micro framework like Silex, in Symfony 2 you remove features. So I turn off internationalization, I disable the doctrine ORM. In Silex, I layer each feature on using a service provider. So next, let's talk about Twig. So if you use the Silex skeleton that we talked about earlier, all these services are baked in. But we're just going to add feature by feature. So integrating Twig is relatively straightforward. We just register the Twig service provider and give a path to our templates. In this case, the Twig path is our current directory of one level to templates. And then I can start to use the Twig service to render templates in this application. So here for the home page, I just want to render the index.html Twig template and bind it to the home page. So now I have a home page using routes and that I can reference with a Twig template. And if I want, I can create layouts and base layout, etc., and extend it out. So this is all relatively straightforward. Translations work the same way. If you need to add internationalization to a project, maybe you should start to think about using the full stack framework. But it's very easy to do for a simple application. In this case, we're just going to register the translation service provider, register some dictionaries, define the default locale, and then pass in a dictionary. In this case, we pass in the dictionary as a simple PHP array that maps hello and goodbye. And then we can use the trans tag just like you would in a Twig template, but from our PHP controller. So in this case, we just access the translator service and access the trans method and pass in the message that we want to translate. Any questions so far?
What happens to the locale parameter?
The locale fallback. So you can parse that or you can manually
So
specify it.
in the definition, in the get method.
Yeah, so it's just a way to go to /en. We treat underscore locale as a special parameter that will set the locale, the current domain, or the current dictionary.
So
So
here,
/en/hello/some name would return the English version of hello in the world. And if I went to /fr, it would return the French version. Or you can manually set it. But out of the box, we just manually parse it. If you define underscore locale, we'll automatically parse it out. And then you define the default here. So I want to default to English, but if I want to switch between the two, I can go to /en or /fr.
so the parsing of the locale parameter is like black box magic here.
Yeah, in this case it is.
Okay.
It actually works the same in Symfony 2, out of the box. But you can completely tweak it. This is just by default. Go ahead.
Just a short question. Right now, the providers you're talking about are mostly like wrapped Symfony components.
Exactly. So what you'll notice about all of this functionality is almost all of these providers simply wrap a Symfony component and expose it as a service to the container. Later in the talk, I'll show you how to create your own providers, because once you start to scale an application, you need to add maybe a Facebook provider or a Twitter provider, and maybe I want to treat my controllers as services and just expose all of my controllers as additional providers. So that's exactly what we're going to be doing in a moment. Just with forms and validation works the same way. So I can register the form component in Symfony 2. And in this case, I simply want to call the form service provider, which will expose all the form building utilities from Symfony 2. And then I can register a form just like I would in a Symfony project. So here we can see we create a form factory, create a form builder. Actually, it's a little out of date, but gets the idea across. I can register a name field and an email field. And I can process a form. If the request is a post, then I want to bind the form and validate it. If something's valid, if something's invalid, I want to show the form with errors. Otherwise, I want to process it with some logic. And that's exactly what we do here. So if the request get method is a post, yes, it's a little out of date. We can bind the form to the request. If the form is valid, we can do something with the data and redirect. Otherwise, we simply proceed processing the view and show the additional error messages. Now, what you'll see here is this is just building a form. We're not actually doing any validation. So let's add the validator component so we can start to validate these forms. And all that means is we can start to register constraints for each form field. So here, we're going to register the form service as we had earlier, but we're going to add the validation service and the translation service so that we can translate form validation errors. The same exact form, except for this time we're going to add some constraints. So I want the name not to be blank, and I want it to have a minimum length of 5 characters. And then I have an email address that I want to specify as a valid email address, etc. And then I can process the form. I can use a tweak template to build the form, just form widget, just like we would use in a Symfony 2 application. Obviously, this is all the defaults, very simple form. And then I can process the form like we did earlier. Relatively straightforward. So oftentimes you need to add some level of caching, or you need to add interaction with databases or web services, so there's providers for all of these. So in this case, we want to leverage HTTP's caching system and the HTTP Foundation component to be able to provide interaction with the reverse proxy. So in this case, we're just going to register the HTTP cache service provider. Now I can start to set cache tags on all of my templates. So here, when I register a response, I'm simply going to return a response of 200 and specify a cache control header of smaxage 5, so shared max age of 5 seconds. Just like you would in Symfony 2, again, all of these are going to be the same. I register a provider, the provider exposes a service, I can leverage that service inside my code. Now again, one use case that I like for Silex is being able to build very lightweight APIs. Oftentimes, in order to do that, you need to access some sort of data store. Everyone who's used Symfony has likely used Doctrine as their default ORM. What this will actually do is not expose the full ORM, but just the database abstraction layer, which is really a wrapper around PDO. So here we're going to register the Doctrine service provider. We're going to pass in some database options like the path to my database and the driver that I want to use. In this case, I'm using simply a SQLite database, and I'm passing in a path to that app DB. Once I have that, I'll bootstrap the service, and then I can start to run SQL calls directly from the DB service. So this is, again, just a wrapper around PDO. So if you use PDO, you can automatically use this here. In this case, I just want to call appdb fetch associated array of select star from table. So if I wanted to build a really simple API, you can start to wrap the service and simply glue a route to a controller that makes a database lookup and returns the result set as JSON. And that's exactly what we're going to do in the next slide. So here we just want to go to /to-do/id. So I'm going to create this is a very simple, obviously you don't run this code in production, but the idea here is to illustrate the concept of mapping a to-do for a single item. It can be done in a few lines of code. So here we just want to map the /to-do/some-id, and we want to return an object for the to-do item. So in this case, we're simply going to select star from to-do, where ID equals the ID that we passed in. If we don't have a result set, we want to abort the request and show a 404 page. Otherwise, I want to pass the to-do list to JSON encoder. So that's all we do here. So appdb fetch associative select star from to-do, where ID equals the ID we passed into the URL. If there's no to-do, I'm going to abort the request. The to-do does not exist. Otherwise, I'm going to return a JSON encoded version of the to-do database item. So this returns an array. This simply encodes the array to JSON and spits it out as an HTTP response. You could very easily scale this to handle more than just a GET request for a single to-do item, but this is a really basic idea. So there's a ton of third-party services you've probably used. If you're in the Symfony community, you've used Doctrine by default. If you sent email, you use SwiftMailer. If you want to interact with logs, you probably use Monolog. So again, we're just going to register a logging service here. So we'll just call register Monolog service provider, pass in the Monolog log file location, and then we can start to interact with the log. So we can call the Monolog service and add a debug message. And the same goes for SwiftMailer. So here we can register a new SwiftMailer service. If we want to post some feedback on contact form, process the form, we can simply create a message using Swift message. Again, slightly out of date, but the basic idea stands. Call appmailer, send this message, and return a response. Thank you for your feedback. So all these are quite similar. Now the question is oftentimes, when do you switch from a micro framework to a full stack framework? And this is where it gets a little bit ambiguous. So I like to think that if you really require security and authorization layer, you should probably be using more of a full stack. But for very simple use cases, you can use the security provider, the security service provider that's built in, which exposes the entire Symfony layer to a Silex application. Now, if you've ever used the Silex as the Symfony security layer, it's not exactly straightforward. There's a lot of components in there. It's very hard to configure out of the box. So what you're going to do here is you're just going to have an admin protected by a basic username and password that we've hard-coded here. So we register the security service provider. We create a firewall. We register the URL, so anything at /admin we want to apply to this security filter. And then we're going to hard-code the list of users. Now, obviously, this isn't a real-world idea, a real-world example, but this still works. And then if we want to process it, just like in Symfony, you can get the user's token, you call the security service, get token, that'll pass you a reference to the user. Now, oftentimes, I think you should, if you really do require a full security layer, you should probably be using a more full-stack framework. But what is a full-stack framework? So obviously, Symfony 2, everyone here is well familiar with Symfony 2. But what makes Symfony 2 nice is that oftentimes you need to collaborate with a large team. You need to have a default set of conventions. You need to have a default configuration. There needs to be a way to do it the right way. Anyone who's worked on a team understands that the right way is often highly debatable. So Symfony 2 provides a default structure, default conventions, it provides a right way to do things, and it provides a standard configuration. So again, in Symfony 2, you remove features. In Silex, you add them. You just layer them on. But more importantly, with a full-stack framework, you can go to symfony.com and just reference the right way to do this. How should I use the security layer for this certain setup? What's the right way to manage controllers in this environment? All of that is defined. Even though you can completely customize it in Symfony 2, there's a default convention that says this is the default Symfony way to do things. In Silex, we just turn the monitor off. There we go. And then we turn it back on in Symfony 2. So, so the idea here is simply that there's the right way and it's referenceable. So when you're arguing with your team about a convention, you can say, hey, this is the Symfony way to do it, it's documented. With Silex, because there is no default structure, because there are no conventions, you have to make every decision yourself. So how do you scale Silex for larger applications? It's about exposing new functionality with service providers. How do you move out of a single file? So the application I showed earlier with Hello World, everything lives in the index.php file. It's only 10 lines. It's really that simple. But often, as you scale out, you need a place to put your views, you need a place to put your controllers, you need a way to register third-party services and manage configuration across different environments. So that's where you start to have to think about how should each one of these pieces work and how should we structure it. So adding support for databases, caches, third-party services, interacting with them with Guzzle, sending email with SwiftMailer, etc., are all decisions that you have to make with Silex, whereas in Symfony 2, there's generally a right way to do it. And then the other piece is how do you define controllers as services and simply register your services and make them self-contained? So we'll walk through each one of these. First thing to point out is that just like Symfony 2 has a large bundle community, Silex has a large extension community of service providers. So if you need to interact with Ascetic, if you need a Memcache client or use Guzzle as a client to interact with Mongo, Redis, Cassandra, et cetera, there are extensions and service providers already available and built and supported by the community. But oftentimes there's a library that's obscure that you only use or something is internal to your company, so you need to create your own service provider. So let's walk through that example. So in this case, we're just going to integrate the Facebook SDK to provide Facebook authentication to a simple application. Relatively easy. A lot of applications these days have Facebook login as a service, so I figure this makes for a decent example. Again, in Symfony 2, you have a much more powerful dependency injection container that can understand there's compilation phases. It can have different files. It supports many different file loading from XML to INI, YAML, annotations, etc. With Simple, with Pimple, it's quite simple. There's a service provider that interacts with the container, and that's it. And the service provider is very lightweight. So let's define how that works. So if we're just going to drop the Facebook SDK into the existing project we had earlier, all we have to call is app share, and that's what exposes a service to the container. So in this case, Facebook requires an app ID and a secret. And in order to use the Facebook SDK, simply instantiate the Facebook class and pass in an array that includes the app ID and the secret. Relatively straightforward. Now, the thing is, this is fine for a one-off project where I just want to expose the service, but if I want to make the service available to the community, I need to package it up as a provider so you can just register Facebook service provider. It's extremely easy to do here. All we're going to do is wrap this in a class with a register method. So here, the Facebook service provider implements the service provider interface, and the only thing the service provider interface provides is a register function and a boot function. So here we just want to register the service, so we'll wrap the same logic we had earlier. App share, use the app, return a new instance of Facebook with this app ID and secret, and we'll simply wrap it into the Facebook service provider where we call register the application, and then the code is the exact same. We just want to share the Facebook service, which is returning a new instantiation of this Facebook class with this app ID and secret. And now we can drop this into any project, we can post it on GitHub, and we can make it available for the community. Now, your question earlier was, hey, most of these providers look like simple wrappers around some other library. Well, this is exactly what that does. Facebook provides a PHP SDK that's really straightforward. In order to use that in our Silex project, we simply want to wrap it with a service provider interface, and then we can use it in any project. All the service provider does is show how to configure and how to basically boot the service and register with container. Now, if we want an application that actually uses the Facebook SDK, so we want all users to have to sign in with their Facebook identity, and we want to access their user, it's as simple as registering the Facebook service provider, passing in our app ID and secret, and then we have the Facebook service that we can use later. Now, if you haven't used the Facebook SDK, it's relatively straightforward. If you call get user, it will redirect the user to sign in. Once they've signed in, it will return a JSON response to their user profile. So here, for all users, we want to call user app Facebook get user. If they're not authenticated already with the Facebook SDK, not necessarily the Symfony 2 layer, but just the Facebook SDK, this will return the user to sign with their Facebook credentials, and it will return them back to this page, and the next time you call this request, it will have a JSON response to the user's identity. So here, if we just wanted to return that, we call app.json, and that would encode the user object, and JSON, we just return that to the user. So this is, you can pretty much apply this to any library. So the Facebook's a simple example, but this works for any library that you use, anything that supports for Redis, Memcache, Puzzle, et cetera, et cetera. Any other questions so far? All right. So the next thing you can do is add controllers as services. So this is a very crude example that I pulled directly out of the Silex documentation so that you can reference it later. Most of these examples come out of the Silex cookbooks directly, so if you want to follow up on this, silex.sensiolabs.org, pretty much every one of these is its own cookbook. Now, oftentimes, as you add many controllers to a project, you want a better way to manage them than just putting them in one file. So a way to contain them, make them encapsulated, is to create a class that is dedicated to that particular service, or that particular controller. In this case, we're just going to expose a very simple way to grab all the posts from JSON using Docker. So we registered, this is a little skipping some initialization stuff here, but the idea here is you register the service controller, service provider, and then I can simply share a post repository. So in this case, it's the Doctrine2 post repository. And then if I want to map a URL, I can simply map post.json to this post.repository find all. So find all the posts from this repository and JSON encode them and return that as my response for post.json. So as I add more functionality, I can wrap these in classes and just map the routes to that class. In this case, the only thing that I'm really exposing is the Docker and Entity Manager's repository as a service. In this case, it's the post.repository service. Okay, so oftentimes you need a lot more than what I just shown, where you want to be able to bootstrap from, instead of from zero, you want to bootstrap with some level of foundation. So there's a bunch of great open source projects that have stolen all this code, borrowed all this, open sourced all this code from, and it's very easy to get started. So if you want to start with everything, you want HTML5 boilerplate with Bootstrap and Twig and Docker and Memcache and all these providers registered by default. There's the Bootstrap Kitchen Sink Edition, so the Silex Kitchen Edition. And what it provides is a bunch of examples for how to use Docker and how to use the security layer for an application that looks like this. So let's actually just dive into that code, and hopefully we don't fail here. Of course. All right, obviously very easy to read. Okay, so let's zoom in and hopefully this works. So what the Silex Kitchen Edition provide, actually let's take a little step back. So if we take a look at the Silex Hello World, all it is the vendor directory with our web directory and a composer JSON file. If we open up that index.php, it looks like this. Relatively straightforward, Silex application. We map a route /hello /some parameter, and this is the entire application in 11 lines of code. So oftentimes you need a lot more functionality than that. So let's look at a more advanced example. So here we're going to take a look at the Silex Kitchen Edition. Hopefully people can read this. All right, so the idea here, again, all of this stuff is available at github.com/Dustin Whittle. If you see the SymfonyLive repository, all these examples are built in. Simply download the repository, run Composer, install, and the apps are ready to go. Now the idea here is that this has a structure. So if I need, the simple structure we started with earlier is the Silex skeleton. So in this case, I have a config directory for dev and production. In dev mode, I simply want to register the monologue service and log some additional. So there's two ways to do this. Usually in development environments, you want to have some developer features. So I want to turn on a web profiler and I want to enable logging. But in production, I might not necessarily need those services. So in this configuration, we have a way to manage dev and production. So production really has nothing in it. Always specifies some paths to some twig templates. And in dev environment, we want to turn on the monologuing service and we want to turn on the web profiler. So if we go back, we now have a place to manage all of our dependencies. So what you'll first notice is that we have index.php and index_dev.php. So just like in Symfony 2, you have two environments, dev and production. The front controller for the production environment looks like this. So what you'll notice is that the code is very similar to what we had earlier, except where we moved some of the logic to different files, so they're contained. So my controllers live in one place, my configuration lives in another place, and then I have the base application. So if you take a look at that, base application, all we're going to do is specify a new application and register all the service providers that we want to use across the entire project. So everything we talked about earlier, register the URL generation service provider, the twig, and the service controller provider. Next, we can take a look at the controllers. So in this case, because we want to manage exceptions appropriately, we can map how do we handle errors and how do we load the rest of the controllers. So in this case, I simply want to look for, depending on the error message, switch between 500 or 404. But more importantly, all we want to do is define a route by default. So the Silex skeleton, this is the entire logic for Silex skeleton, which is I want to render a twig template for the homepage. Relatively simple. We registered this twig service provider earlier, so all we need to return here is a render. So just like in a Symfony 2 controller, you can just call render and pass in a template. Here we're just going to call the twig service directly and return a rendered template. And then we want to bind it to the homepage. All right. And inside of our homepage, again, if you've used Twig, all of this should look very familiar. I extend some base layout and then I augment that with the code for this particular view. Now the reason I show you all that is this is as simple as a Silex application gets, where you just have a simple way to manage configuration environments, you have a simple way to manage controllers, and you're using Twig for a template in there. I think this covers the use case for most Silex applications. But again, if you need something more than that, take a look at the Kitchen Edition, which includes examples for everything you can think of. So let's just run this and show you what it looks like. All right. In theory, this is going to work. Okay, so this is our example from earlier, which should be broken now. So because we're running this page, we get a pretty 404 error in production mode. And this is the Silex Kitchen Edition. So what you'll notice is HTML5 boilerplate, you have Twig, you have Bootstrap by default, so you have some default styles, and it makes it very easy to add functionality. So if you want examples of how to use the security layer, there's an example here. So if I want to log in, I can manage user state. If I want an example of how to use HTTP caching, there's a caching example. If I want to understand how to interact with forms, there's a form example, and the same thing for document. So let's take a look at some of the code that actually powers this functionality, because I think that's the most interesting part. So we'll close this, and let's take a look at the Silex Kitchen Edition. So just like earlier, we have an app.php, except for this app.php, it looks a lot more complex because we have a bunch more services that we need to provide some configuration for. So we're using HTTP caching service, we're using the Docker and devel service, we're using a translation service, and we're using a security layer in the Silex application. And all we're doing in the app.php class is bootstrapping all this and defining the configuration so that we can use these services later on. So honestly, this is very readable from way back there. But the idea here is simply register all of my service providers. In this case, it uses everything because the idea here is it's an example demo app. I'm going to actually have to specify a way to manage users in the security layer. I'm going to register the translation service provider and tell you where to look up the translations from. So if you used the Symfony 2 project before, which I believe everyone here has, most of the time you define all of this in YAML, and it gets parsed out for you. Here we're just specifying in PHP code. This is actually what most of the time Symfony does underneath. Okay, so let's go back. So for the kitchen edition, again, we have a console component. So because we want to use the aesthetic library, we need to define a way to dump aesthetic files. So you have a bunch of console components. What I said earlier is that Silex is never going to have a console as part of its core framework. But that doesn't mean you can't use the console library in Symfony 2 to build your own. So if you've used aesthetic before, you know that you output your optimized files by running aesthetic dump in production mode. Well, we need to actually expose this functionality into our controller. And then you can augment this as much as you want. So there's a bunch of custom tasks as well for managing doctrine schemas, databases, et cetera, et cetera. But again, what you'll notice is all this lives in one file, and that file is console.php, and I can add as many tasks as I want. And then we have the same thing for our controllers. So in the controllers, we have a new way to manage each service. So this is a bad example because it doesn't expose them as services. But the idea here is that you can add complex logic. Sadly, I can't see this, but here we go. So for basic homepage, that's the logic. I just want to interact with the session service, set some flags so that they show up as errors in our homepage view. And I want to return a twig template, a rendered twig template for the homepage. And that's what provides this. So we have some flash messages that we send every time, and I have a homepage template, relatively straightforward. And then you can add logic on and on. So the reason I wanted to share this is because I think this is a really complex example that takes advantage of every service provider and shows you how to interact with each service. So if you want to add Doctrine to your project, it's really easy to reference this. If you want to add caching, etc. Now, it doesn't follow some of the best practices, like moving your logic outside of a controller's PHP file. So let's take a look at another example. Okay, so we went through this. Now, I think the to-do list is the new hello world. So let's take a look at a to-do list example that provides Silex as a JSON REST API and uses Backbone.js to interact with that REST API. So that all the templating logic lives on the client side, and the only way you interact with the server is via a REST API. So again, I've open sourced all this code off of GitHub. So this comes from an open source repository. And what it makes use of is Silex, Twig for templating, and Twig.js for rendering JavaScript templates using the same syntax that you would as in Twig on the server side. And then it uses Backbone for the JavaScript library to have a single page application, and it uses Bootstrap for all the views. And what it looks like is this. Relatively straightforward. We have a to-do list REST API that we build using these views. So here we're just going to build a to-do list in JSON that has some interactions. So I can list them, I can mark them as finished, and then I can create a new to-do list item. So let's take a look at the code that powers that. So again, all these are available on GitHub, so I'd encourage you to actually check out the code on your spare time and understand exactly what's going on. So here in our index.php or front controller, again, just like earlier, we're going to include our autoloader. We're going to register the app by requiring the app.php and register a production configuration. So these all have the basis of the Silex skeleton. And then we can drill down into our code. So we have a place for our views, where do our templates live, our vendor repositories. Let me zoom in a bit. Place for our code, some resources, a cache directory because we actually use the HTTP cache as part of this, and then a console component because we want to expose some command line tasks. Now the most interesting bit is here we have a to-do list. So we have the to-do controller. So now we've started to split the logic out across files and we start to contain this. So here we have a controller, which is simply a to-do controller, and we can take a look at our actual app. So here Let's drill into each one. So we have a to-do model, which everyone's probably seen is a very simple version. It's not a doctrine model. All it is a PHP plain object that maps some to-do properties from array to array, and then setting each property on the object. So you don't need to know doctrine knowledge to make use of this. And then we have the Silex provider, which exposes the Twig JavaScript service. You don't really need to know this, but just like we created the Facebook service provider earlier, we want to use Twig JavaScript service. So there's a provider that wraps that. And then we have our logic. So here is our base controller. So to represent the home page, all I want to render is the index.html Twig template. And then for each to-do item, I want to register that as JSON. So if we interact with that, you can see the actual API. So if you're using Doctrine, this would be a little bit simpler, but this is a relatively straightforward way to map a to-do list controller. So I want to have /API/to-do, and I want to support REST for this to-do list model, the main object. So we're just going to map this to, for app get map /API/to-do to the list to-dos method, and all that's going to do is select all the to-dos from the database that aren't finished, or order by is finished rather, and JSON encode the response. So when I go to /API/to-do, I can get all the list of to-do items via JSON, and that's 3 lines of code, 4 lines of code if you include the route. And the idea here is that each one of these, I can get the entire list, I can get a single entity, in this case just a to-do item, JSON encoded, I can add a new item, and I can update an item. So basic REST API for to-do items here. And then you can interact with that using Backbone. So we have some JavaScript, CSS. Let's just take a look at the idea here. So in Backbone, you have to describe a model, and then you describe controllers and models to how you actually interact. So I'll skip the introduction to Backbone. But the idea here is that I specify a router in JavaScript that maps to all of the APIs that I mapped out earlier, and the views associated with each API. So I don't want to go too far down the rabbit hole with Backbone, but the basic idea is this maps a list component, a view component, and an edit component to our underlying API. And then builds the UI logic to actually process that. But the idea is that I can build a very lightweight REST API with Silex, and then I can build all the view functionality and something like Angular, or Backbone, or Ember, whatever your favorite flavor is. And I think this is a pretty good use case for Silex, is lightweight APIs. And I think that's what most people end up using it for. So let's switch back. Okay, so when does Silex make sense? For simple applications, I think for simple RESTful APIs, and oftentimes Silex can replace simple Symfony 2 applications. The problem with Symfony 2 is that you don't always need the full stack. Oftentimes I only want a few services, and you can do that with Silex. With Symfony 2, in order to disable all those services so that you don't incur the overhead, it's quite a lot of configuration to go and turn everything off. By default, Symfony 2 makes it really easy to leverage all the services, so they're all exposed. With Silex, you start with nothing, and you add on each layer that you need. So again, RESTful APIs is a perfect example for this. A ton of different people use Silex, so this list is at least 2 years old. But large companies, I think it's the backend for BBC Mobile. I think somebody in the room probably wrote this. But there's a bunch of different applications that are used, so it's tried and true, it's used in production, it's supported by SymfonyLive, you can get training on it, there's plenty of documentation, and there's a vibrant community full of third-party service providers. So when you use a full stack, I think anytime you need a full ORM, like if you're using all the functionality in Doctrine and you're not just using a simple database abstraction layer to interact with PDO, you should probably think about using a full stack framework. When you need a more powerful container, so again, Pimple is a very simple container. All it does is allow you to expose services to a container. But sometimes those services need complex configuration, or you need orchestration of the configuration, and Pimple's not going to do any of that. So if you need to manage complex services, you should probably stay away from Silex. Again, because it's built by SymfonyLive and part of the open source community, there's a ton of documentation support around it. If you need help, you can go on IRC. People are very friendly. I think most of this community is probably in there at some point. And then again, it's on GitHub, so the URL is actually a little out of date, but if you go to github.com/silexphp, you can contribute. Again, it's open source. There's plenty of documentation on silex.sensualabs.org. So if you have any questions, please use the leverage of community, and I'm more than happy to walk through anything you'd like to know. But again, silex.symfonylive.org, all of these examples come directly out of the codebooks and on the Silex website. And if you need third-party service providers, you can see a full list on silex.symfonylive.org. So any library that you probably use Redis for connecting to Redis, there's a library for that. Memcache, Cassandra, et cetera, Encourage everyone to contribute because it's open source. Nothing's better than a pull request that fixes an issue instead of a complaint about a problem, so feel free to contribute. And any questions?
Would you discourage the mixing of the two maybe at some point, like having a full stack framework like Symfony for maybe the whole front-end application and the back-end too and stuff like that, but then at some point needing some really fast REST API at some point for interaction on the front-end side, and maybe just take the entities via Doctrine or something like that, but only the parts that are really without booting the entire Symfony application up every time I have a...
So I think it is a mistake to assume because Silex is a micro framework that it's going to be faster than Symfony 2. Symfony 2 is much more optimized and a lot more effort's been put into making it fast. That said, yes, I've seen many projects evolve from what was a simple Silex project into a full-fledged Symfony 2 project. The best way you're going to be able to do that is to move your controller logic to providers, which are really just making your controllers services. Because then if you move it to Symfony 2, you can just map these routes to these new services and your migration's done. Relatively, sort of glossed over a lot in the process, but it's that easy. I think that you should probably put a little more planning up front. If you know that it's going to be a very complex application, you're probably better off to start with Symfony 2. If the scope is very small, I would say always stick with Silex until you need something more powerful. But I think it varies for every project. But yeah, if you build it the right way, which is really about making your controllers self-contained, then it's very easy to move those controllers into a Symfony 2 project.
The thing is, we started with Symfony 2, and now the question is that maybe because you said that Silex is very good for, as an example, the REST APIs, that maybe we could take some of these REST requests out of our Symfony project because it tends to get slower.
Yeah.
And do them by Silex.
Yeah, absolutely. So depending on how the Symfony project is built, it might be a little more difficult. But if you're having controllers as services in the Symfony 2 project, it maps just as easily in the reverse, which is just mapping routes to services. Yeah. Any other questions? All right, well, thanks for joining. You can find all these slides on speakerdeck.com/Dustin Whittle. I glossed over a lot of the examples, but in the notes of these slides, there's much more complex examples, and the GitHub repository is a source of truth, so I would encourage you, if you're interested to find out more, follow up on speakerdeck.com/Dustin Whittle and go to github.com/Dustin Whittle and grab the repository and get started with Silex today. Enjoy the rest of SymfonyLive.